Yeah, good evening, all. I will wait for another 7 minutes. So let others join.
A very good evening to one and all. Myself, I am Lohita from EC Department of Brilliant Institute of Engineering and Technology. Firstly, let me wish you a happy Ganesh Chaturthi to one and all. Today's session will start in 2 more minutes. Let us wait for 2 more minutes. Let other participants will join.
Hello.
Good evening, sir.
Good evening, Dr. Narayan sir.
Sir, we'll start the session, sir. So, madam, you can introduce yourself so that
Okay,
we
sir.
can introduce.
Yeah.
Hello.
Once again, a very good evening to one and all. Sir. Okay. Once again, a very good evening to one and all. I'm Lohita from EC Department of Brilliant Institute of Engineering and Technology. Once again, I want to wish you all happy Ganesh Chaturthi to one and all. On this special day, I welcome you all for the third day of ATAL FDP program on emerging trends in VLSI design for signal processing and communication system. Let me introduce our today's resource person, Dr. Patiti Krishna sir. I'm honored to introduce about you, sir. Dr. Patiti Krishna sir is from Netaji Subhas University of Technology, East Campus, Delhi. Patiti Krishna sir has obtained a bachelor degree in Electronics and Communication Engineering and master's degree in digital systems and computer electronics, and doctoral degree in electronic and communication engineering from Jawaharlal Nehru Technological University, Hyderabad. And he has over 20 years of teaching and research experience. Presently, he is working as Associate Professor of EC Department at Netaji Subhash University of Technology, that is East Campus, Delhi. He has awarded 2 patents and 3 Indian patents published, around 50 international journals published in SCIE Web of Sciences, and Scopus indexed journals to his credit. His research interests include digital systems, wireless communications and networks, AI/ML for wireless communications and quantum communications. And he has guided several students for BTech and MTech projects. And he's guided, sir. And he is guided 1 PhD scholar, and he's guiding 3 now. He organized 2 short-term training programs sponsored by AICTE and has delivered lectures in various workshops and seminars. He has organized various training programs for faculty and students in the field of ECE. He has been a reviewer in various IEEE conferences, editorial member of IJE-TST, reviewer of IIENG international conferences and advisory committee member of various international conferences, and has chaired sessions in conferences. And he visited Hong Kong, Malaysia, Singapore and Japan, presented papers in IEEE international conferences, and he received Young Scientist Award from IO Chennai in 2018 and Professor of the Year from Tutors Pride's Ideal Teaching Award in 2018. And he is a member of IEEE, lifetime member of Institution of Electronics and Telecommunication Engineers, that is IETE, and a lifetime member of CSI, and a life member of Indian Society for Technical Education, ISTE. And it is our privilege to have him with us on this special occasional day to share his valuable knowledge and insights. Sir, over to you, sir.
Hello. Hello.
Yes, sir.
Yes, sir, we can able to hear you, sir.
Yes, yes. Thank you very much, madam, for giving a wonderful introduction about me. So firstly, I would like to say, I wish you happy Ganesh Chaturthi on this auspicious day. I am the one of the person to actually participating your esteemed FDP program organized by the brilliant group of technical institutions by coordinator Dr. Naraya sir and his team. My wholehearted thanks to them. So here today I am going to be discussing about one of the emerging techniques what we are going to be used in advanced wireless communication techniques, which is called as signal processing technique, advanced wireless communications. The first few PPs I'm going to be discussing about importance of the signal processing wireless communications of wireless communication, where Marco was invented in telephony. Then followed by the evaluations of the wireless communication systems. And low latency, we are using the technology in the field of MIMO, which is called as massive MIMO. Then I am going to be a little bit covering on multiple access techniques, whatever we are used up to now, what we are going to be supposed to be proposed and implement fifth generation cellular and behind the wireless communication networks. So these are the contents I would like to go in to discuss here. The first one, so that is called as, so hope so the PPT is clearly visible to you all.
Sorry, your voice is like a little bit.
Yeah. So here, as we know that signal processing play a crucial role or vital role in not only in modern wireless systems, is also in processing of digital processing and all the techniques. So which includes particularly with respect of modern wireless communication systems, networks. Processing is in order to improve the system capacity by coverage of networks in a particular geographical area. As we already studied as the part of basic introduction modern wireless communication system, so which is called as how to increase the capacity. How to increase the capacity in cellular networks, we may be use frequency borrowing from the adjacent cells, and that is the one techniques. We may be used called as cell splitting techniques. So this is the simple coverage areas. All the cell coverage area can be shown in the hexagonal shape. And small cell base station can able to cover the maximum limit 13 kilometers for a 13 kilometer distance. That may be called as one geographical area. So this is the, and one more technique, sectorizing. The cell can be divided into various cells that we called as wedged shaped sectors, 3 to 6 sectors for cell. Each within the one cell set, subset cell can be allocated the channel. Channel allocations can be defined depending on the dynamic allocation as well as the static allocations. So I'm not going in detail discussion in this all. Of course, you all are who are background and communication engineering faculties. After the improving the capacity, I'm going to just giving the brief discussion of the success of wireless communications system as on date. So now we are using, we name it as fourth generation cellular system, LTE advanced either generation cellular system. So how many devices, traffic can be used for year or per person? So if you look at the here two diagrams I mentioned here, the one is called as connected devices used for person, and at the same time data can per person. So if you look at the data up to this data is up to the 2022. If you look at the data traffic, almost this is a very low data. Whatever I am showing here, the 9.1 gigabytes for month is the month per person for device only. Where initial stages of data traffic is started, that was got on 60 in the terms of megabits per second only. At the same time, if you look at connected person, 2 to 3 devices per person can connected, and use topic is almost 45 to 65% of data is used in as on date. So with respect data rate point of view, how can data rates techniques we may be supposed to be used to achieve the whatever we are using the 5th generation cellular system that may be started as 10 gigabits per second. So whether we achieved that much of data or not, if we achieved, what methods we may be supposed to be proposed, that will called as a multiple access techniques for advanced communication systems. We next later slides we can see. So again I am just showing here, but just I am taken as a small example. So what we can is that from the Martin Cooper law, if you see here, data rate is almost increasing year by year. So every year, almost 125 times the data rate are going to be increased by in the form of broadband connections. Broadband connections. So here I am shared here a simple wireless communication throughput calculation or coverage area. So here, by using this formula, what we can say, throughput is equal available spectrum into cell density and spectral efficiency. So by using this formula, we may be find three main components, that may be whether more bandwidth can be allocated to a specified communication system, which is called as either the 4th generation, 5th or proposed 6th generation cellular systems. It densified by adding more users, more cells with independently operating access points. That may be considered as a second motivation factor. The third one, the efficiency of the data rate, efficiency of the data transmission for cell and for a given amount of data. So here, by improving these three parameters, we may be achieve the expected data rate, namely, if you consider as a 5th generation cellular system, 10 gigabits or 1 gigabits per second to 10 gigabits per second amount of data rate. So if we see this table, it shows that when we are expecting the spectral efficiency, higher spectral efficiency, we may be preferable massive MIMO, massive multiple inputs, multiple output communication technology proposed here to achieve higher spectral efficiency. As we already know that the spectral efficiency is simply defined as the amount of information rate that can be transmitted over a communication system in a specified bandwidth. If you are taking as a 4th generation cellular system, 1.3 megahertz to 20 megahertz bandwidth. It is a scalable bandwidth. And if you are considered as a 5th generation cellular system, we may be used as FR1, FR2, frequency range 1, frequency radio 2. So here, as we increasing the cellular mobiles, evaluations from 1st generation cellular systems to expected data, expected evaluation 6th generation cellular system, only key focused challenges are high mobility. Second one is massive connectivity. Third important challenging factor is low latency. So finally, whether we achieved expected energy efficiency and followed by the capacity also in terms of the spectral efficiency. So let us take as a high mobility example. Nowadays, wherever we are seeing recently, we have Sindur, so many drones are moving or targeting to reach wherever we are targeting. On that locations, the speed, the mobility of the vehicle almost 600 kilometers per second. The speed we are going, that we called as unmanned aerial vehicle speed. So when we are, whether we achieving that mobility with respect to that cases, what kind of modulation techniques and multiplexing techniques we may be used. In that cases, we are proposing or we are still under the processing studying that we called as OTFS, high mobility users. OTFS is an orthogonal time frequency space modulation multiplexing techniques and modulation. So that cases, we are achieving high mobility unmanned aerial vehicle connections. And also, it is also related to massive connectivity. This is called massive machine type communication. This is the one of the user scenario in 5th generation cellular system. As low latency. Now, if you take it as a 5th generation cellular system, ultra reliable low latency communication systems. Ultra reliable low latency communication system, which is nothing but a what we can say driverless cars, whether we achieving the latency within the expected data rates or not. So I'm just here displayed and just shared brief summary of evaluation of wireless communication system. What kind of multiple access techniques used from the 1st generation to till date 5th generation cellular systems. What kind of applications preferably use the corresponding frequency bandwidth, expected data rates. So if you see here, the 1st generation cellular system in terms of the kilobits per second, and whereas 2nd generation minimum 10 kilobits per second to 10 gigabits per second to maximum 50 gigahertz per second. So then applications, whatever we are using now, online classes, online presentations, online SWAYAM classes, all we called as, is possible with the help of this much of data rates are getting. So with IoT and vehicle to anything, broadband wireless access services to behind the mobile broadband communication system. So this is the simple what we can say as evaluation of wireless communication systems. So as I told you already, different challenges in wireless communication. The limited resources are available. That been called as spectrum. Then second one is quality of services, quality of link, whether we are achieving the wireless links are successful or not with low. When we are using achieving quality and spectral efficiency, are we transmitting limited power of transmitter? If we transmitted more power, then again at the receiver transmitters, receiver, we may at the receiver end, due to the non-linearity effect, the more power we are transmitting, then there is a chances to broken of the non-linear. Therefore, in keeping view of all these parameters, how can we maximize the spectral efficiency along with the quality of the link? So that is the one of the solution is multiple inputs, multiple output communication system. That is nothing but a MIMO. So which is called as number of transmitting antennas are using at the base station. At the same time, number of antennas are using at the receiver site. So that will called as multiple antennas using at the receiver, multiple antennas using at the transmitter. So the antennas are spacing independently transmitted by multi. So these all technique is called as space division multiple access techniques, and we allow the space-time signalings are transmitted. So see here, simple, the capacity benefits. If we see here this diagram that will called as single input, single output antennas, 1x1 antenna, the achieved the spectral efficiency is 4.3 kilobits per second edges. Whereas if MIMO antennas that we called as taken as a 8x8 antennas, the data rate is 32.3. I mean, spectral efficiency is 32.3 bits per seconds for Hz. That much of data is increasing. If you see one more in this diagram, one transmitting antennas and 1/16 antennas, then again also the spectral efficiency is also not that much level. So this is the importance of the MIMO systems. So this is the simple what we can say has the channel capacity of the single input single output system. C is equal bandwidth B into log base to 1 by signal to noise ratio. This was proposed by the Claude Shannon in the year of 1915 at the Bell Laboratories. So if you are using the adding single array does provide a diversity, again is the fading, but it does not changing the logarithmic nature of efficiency. See here, if you are increasing number of antennas, then we can see M. M is, you can just add one more parameter. M is nothing but a number of receiving antennas. Diversity factors are included. Similarly, MIMO inside, I mean, transmitting antennas, number of receiving antennas, we will get the channel capacity. C is equal B into log base to 1 plus signal to noise ratio. So, may I know, is all of you listening my voice clearly?
Yes, sir.
Thank you.
Yes, sir.
Thank you. Thank you. So here, where the M is the number of antennas in this transmitted side using and receiving side using. Here, one more point, one more limiting factor when we are using number of transmitting antennas at the base station, number of transmitting antennas using at the receiver end. That is called electromagnetic interference is the one of the challenging factor. How to avoid the spacing between the array of antennas. If you are using the more spacing, then what will happening? So therefore, in order to controlling the electromagnetic interference at the base station, normally we provide the space that we call lambda e by 2. Space is required to provide avoid the EMI, electromagnetic interference, and electromagnetic compatibility. So the final diagram, the MIMO increase the data rates by exploiting the multiple antennas at the transmitter and receiver. So see here, transmitter side and receiver side diagram, where transmitter side we are using the encoder process. After the data, the interleave process is dividing via, and it is parallel data transmission in the through different antennas. There we are using the pre-coding weighting factors in order to separating the multiple signals from the multiple stations. Then channel coefficient H and user data is encoded, modulated, transmitted simultaneously over the multiple antennas to improve the data rates, as well as at the receiver end, high level of interference at the mobile requires a sophisticated and efficient signal processing. So here, the multiple antenna techniques rely on characteristics of spatial signatures which is called as a diversity, transmit diversity, receiver diversity techniques. Intelligent antenna techniques are used. Efficient adaptation of antenna patterns according to the spatial distribution of the desired users and avoid the interference. So let's see here one of the open loop transmit diversity. So the transmit diversity means more antennas using at the transmitter end and less antennas using at the receiver end. So that is called time switch to transmit diversity. The signals are divided based on the timely. Whereas space-time block code, space-time codes, space-time STBC, space-time transmit block codes, STBC techniques, the incoming data, symbol data is spatially distributed among the number of transmitting antennas. So here, if you still focusing on advanced MIMO techniques, we called as multi-user massive MIMO techniques, the majorly focusing research trends with respect to low complexity, high-end performance computing devices, normally using channel detection algorithms, estimation algorithms, and also joint-based algorithms are proposed to provide high performance computing systems. And also we may be proposed to produce, we may propose to get better architectures for multiple iterations between low complexity detectors and error detection decoders, as well as transmitter side encoding techniques we may be used for higher order modulation techniques in order to reduce the complexity at the receivers. So is a play a vital role to provide or to achieve higher data edge. So as we look at the core areas of signal processing in wireless communication techniques were specifically used at the transmitter channel estimations and equalization process, the beamforming techniques and precoders, multiple access techniques for advanced wireless communications, along with resource allocations, modulations and waveform designs, interference management. If you look at the here clearly, as recently there is a one technique is undergoing that is called ISAC, integrated sensing communication systems, integrated sensing and communication. So this is the one of the emerging topic to produce, to study the merging of the various signals, various communication. One is the radar communication signals point of view, one communication signal point of view. How to integrating and to produce the better that we called as maybe visible light communication applications and IoT applications, vehicle to anything applications. This kind of robust waveform design techniques are supporting to produce, supporting to achieve visible light communication and vehicle to anything communications. Here, out of all these, I may be specifically focusing on multiple access communication where I am working and research me and my team is working on multiple access techniques and resource allocations. I may be much more stressing on this point. Yeah, again, I am just going to one back point. So see here, as for the Sony Ericsson data, the increase the demand of the data rate, on mobile. So see here, in the 2020, 2022, 2024, almost 2026, we may be getting 400 and extra bytes per month. Access per byte per month data rate is required. So this is the huge amount of data rate is required. So in this case, the key point to achieve higher data rates in fifth generation cellular system, preferably using technique is called as massive MIMO. As I talked the previously slides called as MIMO. Now immediately I'm extending to massive MIMO. See here, this is one simple base station. It is simply called as a cell site. Now one radio unit is there and m number of transmitting antennas accommodated. See, n number of antennas, m number of antennas are transmitting simultaneously, scattering out the data to the users. That will called m by k massive MIMO. M number of antennas, beams are transmitting n number of users. In this case, massive MIMO is base station with multiple antennas may simultaneously communicating to the users by the sending data or receiving the data at the same time at the same frequency domain, same time frequency gets. And that is the one. And whereas the beam forming techniques, antennas focusing beam form techniques are radio signals directly connected to the users in order to eliminate the interferences. The computation and wide communication challenging in massive MIMO. So here, high front haul bandwidth cable is one cable. Accommodating server is here. The large amount of computation with more antennas or users when communicated, and we can use here. So see here, as per the Core Next 2020, need 28 crores for 64 by 16 MIMO antennas. So can't scale the large MIMO antenna configuration 128 to 32. The single server is not enough to accommodate this much of antenna configurations. So see here how the massive MIMO processing parallelly or pipeline. So here from the remote unit to the first we are doing FFT, where the signal processing techniques are used here. Then after the FFT, we are going to be equalizing the whatever the incoming binary data, which is called as a binary data or digital data. Then after demodulation of the signals at the user end, forward error correction techniques. These are the, if any errors are presented by using the decoding techniques. The next, similarly, from the core networks to the processing is modulation, the pre-coding, where it is here we are using the pre-coding matrix, weights are using, and at the IFFT techniques are used to the remote unit. So the data dependency between stages introduce the communication overheads. So simple, for example, 120 by 30 MIMO antennas with the subcarriers are 1200 subcarriers. So see here, 40 antenna packet, antenna 1 is at a time transmitting 40 packets, and antenna 2 is also same. 1 to 40, 41 to 80, again, and 80 to 120 antennas are sending. Next again, subcarrier set, the parallel users transmitting and the data can be processing. So with each subcarrier speed, approximately 5 kilobits per second at the subcarrier 1 to 400 at the subcarrier parallel points, we may be here. The data will be processed like this. So are we getting scalability bottleneck? The data rate is of inner servers shuffling almost greater than to the 120 gigabits per second at the inner server rate. One more idea, exploiting modern radio units features to avoid the duct shuffling. See here, the data is still high overloaded from the duplication of the data from the antenna 1 to antenna first set. If you are considering the first set 148, so antenna set 1, 2, 3, 4 and so on. Supporting the FFT, the configuration frontal packet segmentation, originally designed for the MTU tuning. Then data will be transmitted. Hydra elimination frontals, shuffling by the leveraging modern radio unit features. So finally, the pipeline progressive reducible data size. So like this. So FFT, the transforming from one antenna domain to the user domain, 100 antennas to the 30 users, then data may be 100, what I told you, greater than 120 gigabits per second into 4 times 32 gigabits per data. And again, it will be converted by wireless signals into user data. We maybe get the 24 gigabits per second for users, for user data. So here, shuffling is more scalable to achieve the data rate. So this is again one more parallelization of the increasing the data. These are the server portions, how the antennas are going. So now, as the hardware setup, as the hardware configuration, this configuration already is tested at the Germany laboratory ITU. So the hardware configuration for accommodate the servers, each server has two 16 core units with AVX to support 100 gigabits per second energy thick cable. So these are the simple comparison data, various existing systems. Hydra support more challenging memo settings. So experiments are more servers, 28 servers, cloud labs, and so on. So by concluding here, the massive memo processing, we show that intra-server communication is a key scalability limited in prior massive designs. Using the features of modern radio units and efficient computation partitioning called as FFT, IFT computation processing, 120 antennas at the transmitter, either 32 antennas at the receiver. So these are the massive MIMO communication system. So now, as I told you, next generation wireless communication system to achieve more and more data rates. The one of the techniques normally preferred technique is massive MIMO techniques. Then the second one is multiple access techniques and multi-modulation techniques. Multiple access and modulation techniques. See, here I am just displayed different stages of or various milestones of developed multiple access techniques from initially 1982 till date. Almost a lot of changes are going, and all are going to working under experimentation. As we know that multiple access definition, we know that simultaneously transmit the multiple signals through a single channel, or to utilize the radio frequency spectrum. That will call multiple access techniques, which may be broadly divided into two categories called as, one is orthogonal multiple access techniques. So which we are, whatever we are studied, OFDMA, orthogonal frequency division multiplexing, code division, TDMA, time division, frequency division techniques. So OFDMA is suitable for the up to the fourth generation cellular system, where if you want to achieve unlimited data rates, what I told you, high mobility, higher data rates, and ultra low reliable latency communication system. By using OFDM techniques, either TDMA or FDMA techniques, is can't provides maximum attainable sum rate of multiple users in a wireless system. Due to this, we may be going to studying non-orthogonal multiple access system. So see here, interdivision multiple access system, LDC, NOMA normally subdivided into two types. One is called as coded domain, one is called power domain multiple access, non-orthogonal multiple access systems. So this is the simple, the basic differences, what we can call as time division, frequency division, and code division multiple access techniques. So the benefit or limitations. As we know that orthogonal frequency division multiplexing is used to avoid ICI, inter-co-channel interference or interference, simplifying transceiver design and to avoid intra-cell co-channel interference. Whereas at the same time, orthogonal multiple access system provides having some kind of limitations. When we use the number of users that can be served simultaneously is limited strictly by pooling up, allocating the radio resources. Here, either orthogonal frequency division or frequency division, radio resources are allocated depending upon the users. When we more users are there, and more radio resource allocations are need to be provided. But by using OFDM techniques is not possible. The second one is careful scheduling techniques with dedicated feedback channel, which may be called as channel state information at the transceiver, CSI, and transceiver at the transmitter and receivers. So see here, as I told you, non-orthogonal multiple access techniques. If you see clearly, non-orthogonal multiple access technique is simply defined superimposing of or multiple signals. Superimposes messages of multiple users can simultaneously transmit the basis of time frequency at the same time is called as non-orthogonal multiple access system. So by using NOMA systems, we are getting improved maximum amount of spectral efficiency, massive connectivity, increase the throughput. So by these three are key performance indicators of the fifth generation cellular system. That is nothing but a improve the spectral efficiency, massive machine type communication, and improve the ultra reliable low latency communication. And also NOMA is is a compatible with other emerging techniques, heterogeneous networks, millimeter wave communication, and terahertz communications, cooperative communications, and cognitive radio communications. So as on date, third generation partnership projects adapted release 14 for release 14 for release 14 and release 16 is suitably applicable for the NOMA systems. If you see here what I told you, point-to-point communication, point-to-point memo, as I already given you last PPTs. So here the high SNR when the users devices are small and cannot fit many antennas. So this is the same, the figures what we use, multiple user domain. So let's see here, non-orthogonal multiple access system with n number of, let us assume 2 users want to communicate with the base station at the same time and frequency. The power can be divided. Power is called as a P. The bandwidth is B. Therefore, the bandwidth can be divided, which is called as required data rates for the user 1, alpha B into log base 2 1 plus P beta by alpha B and naught. Similarly, another power domain users R2 1 minus C. If we here, one more point we may be consider here, may be allocate the resources where the weaker user, that is nothing but a long users, we may be send the more resources, and short users, I mean strong users, we may be send the less amount of the power. So see here, orthogonal multiple access, this is called as a radio region. So this is the symbol. Again, the same mathematical equations also. I mean, of course, there is no much more required on this. You can see here. And here, one more beauty in normal systems at the receiver end, successive interference cancellation used at the receiver end. That is the beauty of the non-orthogonal multiple access systems. So this is the simple equation, same again. Rate regions, then multi-user. Yeah. So that's what that was called as a simple multiple access techniques, NOMA, particularly used for the next generation communication system, where we can supposed to be signal processing techniques applicable in channel estimation and equalization. As we know that channel estimation techniques are various techniques, that is called pilot based channel estimation, semi trained based channel estimation, semi blind estimation techniques, starting with least square, minimum mean square estimation techniques are used to estimate the available channel at the to achieve the better signals. And also the sparse estimations for millimeter wave communication or OTFS, orthogonal time frequency space. So in this case also we may be used. Nowadays estimation AI wireless communication, we may be again used in estimation techniques as well as equalization, zero forcing, MMIC, iterative detection algorithms are used. And these are the different beamforming and pre-coding. One more here, interesting topic or interesting research going on, RIS. This is called Intelligent Reflect Surface Scheme, is get the more speed, the maximum amount of data rate speed to reach the receiving. And that is the one more technique, RIS technique. And Isaac, I told you already, integrated sensing and communication are the best beamforming techniques where the signals and mobile devices signals and standard communication signals both be mixing and sending. That is simple meaning of ISAC, integrated sensing and communication systems. So these are the NOMA techniques we are giving here. The fair allocation scheduling algorithms also required. The fair amount of techniques are proposed here. So then successive interference cancellation used in NOMA techniques, and in order to provide achieve the maximum amount of data rate without suffering any interference. And finally, one more techniques are normally we know that error correcting codes, LDPC codes, polar LDPC low density parity check coders. These are LDPC turbo codes. All are used rated codes. Nowadays, where we can applicable for the 5th generation, we may use fountain codes, LT codes, which is called one of the LT code rateless coding techniques also used for to controlling the error and achieving the maximum amount of data rates. So now again here, artificial intelligence and signal processing. Deep learning techniques also included. The search is research, and most of the researcher academicians are much more focusing nowadays emerging area, artificial intelligence, machine learning techniques to estimate channels and detections. AI driven RIS techniques beamforming. So this is the joint sensing communication, that is nothing but a ISAC. So the future advanced wireless communication trends going to what we can say quantum communications and signal processing, holographic memo. Holographic memo is going one of the technique, terahertz communications. So that's, and the summary what I discussed here, various signal processing techniques involved in next generation wireless communication techniques. So with this summary, I'm going to end it. So thank you. And these are the few references we added. So with this, I am ended presentation. So anyone having any discussion, or if then I can say thank you each and everyone. The personally where what we can brilliant group of institution, my personal thing, sincere thanks to brilliant group of institution on behalf of NSUT, Netaji Subhas University of Technology, to share my views and my research to all the participants gathered from the various locations. So thank you very much. Now over to organizer Dr. Naraya sir and madam. Thank you, sir.
Thank you, sir. Thank you so much. Dear participants, if any questions are there, you can ask.